Morning, everyone. Today we're going to be working on IXL assignment N46. Is a given ordered pair a solution to the system of equations? So before we get into that specifically, let's quickly review the three types of solutions. And even though we're not going to be working with graphs today, these graphs here can really help us picture what we're looking at and what we're actually working towards. So the first type of solution, and it's the one that's the most common, is one solution. It means that there is one answer, or in this case, there is one ordered pair that both lines share, that are on both lines. So in this example here, we can see that it is the ordered pair 2, 1, because that is the point where both of our lines cross, and that ordered pair is on both the red line and the blue line. So that is the one solution, that is the one answer, that is the one ordered pair that is shared amongst both lines. Another type of solution would be no solution. So if your two lines here are parallel, well, remember that parallel lines, they never intersect, they never meet. And so that's why it's no solution, because there is no point in time where these lines will cross. There is no ordered pair that is shared amongst the red line and the blue line. And then the third type of solution is infinitely many solutions. That happens when you discover that both of your equations really end up being the exact same line. And, we can see here it's in purple because if you lay a blue line on top of a red line, blue and red, make purple. So that's why it's colored that way, because these two lines or these two equations are really the same line and all of their points are shared. So that's why it's called infinitely many, because they share all of the points because they are the exact same line. So every single point on that line is considered a solution. All right, so we're going to hop on over to IXL and we're going to see how we can, identify if ordered pairs are a solution. And, remember, it is considered a solution if it is a point that is on both of your lines. It is a shared intersection point. It is a shared value on both your first and your second line. All right, so here we are on IXL, specifically working on skill N46. Is this ordered pair a solution to the system of equations? So in our example here, we are given our ordered pair and we want to know if it's a solution, if it actually works. So if you had a graph, then you could graph both of these lines here and you would be able to see whether or not they intercept. And if they intercept, is it at that point 1, 8? But since we don't have a graph, we're going to talk about another way you can do this. So we can do this through something called substitution. Remember that substitution is when you substitute, is when you replace a number for a given variable. We're subbing that variable out with a specific number. When we look at our ordered pair, remember that the first number is always our x value, and the second number is always our y value. That means that we can take these points here and we can substitute 8 in for our y values, and we can substitute x in for, we can substitute 1 in for our x values. All right, so let's go ahead and do that with our first equation here, because by substituting these values, we're trying to see, does it actually make the equation true? Is it a possible point on that line? So our first equation is 19, actually, let me color code this, 19x plus 3y equals 2. And we're going to substitute our 1 in for x and our 8 in for y. So instead of 19 times x, we have 19 times 1. And then plus 3y. Well, instead of 3 times y, we're substituting 8 in for y, so it'll be 3 times 8. And then that is equal to 2, or we're going to find out whether or not it is equal to 2. So now we just need to simplify the left side of our equations, and we can do that by using order of operations. So order of operations tells us that multiplication is going to come before addition. So 19 times 1 is just 19, and then 3 times 8 is 24. And we're trying to figure out if that's going to be equal to 2 or not. Well, you can possibly figure out the answer already, but let's go ahead and add. When we take 19 plus 24, we get 43. Now, is that equal to the number 2? No, it is not equal. So that tells us that the ordered pair 1, 8 does not fall on that line, which means if it's not on the first line, I don't care, honestly, if it's on the second line, because in order for it to be a solution, it has to be shared. It has to be a point that works for both of your lines. So if you discover that it doesn't work for the first line, then you can just stop and you have your answer of no. It is not a solution because it is not on that line. Now, I'm going to show you that on a graph for just this first one, so that way you can kind of make that connection and you can really see how if you were to graph it, the 0.18 is not on our line. All right, so here we are. I used Desmos's free graphing calculator to do this. I typed in the equation of that line and the 0.18, and we can see that that is not on the line. It is clearly not falling on that line, and that is why we got a false statement. We didn't get the answer of 2. Whereas if we had been given a point that fell on the line, so maybe, this point right here of 1 and 11, 12 of 112, then we would be able to say, yes, this point is a solution. Actually, I said that ordered pair wrong because our graph is counting by 2s. So it would be located at 2 and then 14. So in case anybody wanted to check my work, I messed up on that. So just a quick little reminder here that whenever you have a graph, always be careful to say, is it really counting by 1s or is it counting by something else by 2s? All right, just for fun, let's go ahead and quickly put in that second equation that we had, which was 3x plus y equals 11. And we can see here that 1, 8 does fall on the second line, but because it's not on the first one, it's not that shared solution. And in this case, that solution is right here. That's the point at which would work for both of our equations. All right, so let's head on back to IXL. This is the only one that I was going to show you via graphing just to kind of help you see and make that connection a little bit more. But we're going to do a couple more examples where we just focus on solving it through substitution. All right, here's our second problem here. Sometimes the equations will be given to you in slope-intercept form, and that's okay. The process of this is still the same, in which we're going to substitute our values in for x and y, and then we will simplify the equation, see if it really does work, if it makes a true statement. So remember that our first value in an ordered pair is our x value, and the second is our y value. So we'll be substituting 4 in for y and 1 in for x. So if we look at our first equation here of y is equal to x plus 9, that y is going to be replaced with the number 4. And then our x is going to be replaced with the number 1. And then we have a plus 9. All right, well, in this case, the only simplifying I have to do is addition. So we'll add 1 and 9, and we get the statement 4 is equal to 10. Is that a true statement? No, those numbers are not equal to each other. So here we have another example of no, this point is not a solution. And once again, as soon as you get the answer no, you don't have to try the second equation. You can, but it doesn't really matter if it falls on that second line because it has to be something that works for both. All right, let's check this one out. We want to know if the 0.18 is a solution to this system of equations. All right, so we're going to substitute 1 in for x and 8 in for y. Our first equation is y equals x plus 7. So we are replacing y with the number 8. We are replacing x with the number 1, and then a plus 7. Simplify whatever side of the equation needs to be simplified. In this case, it's 1 plus 7, which is 8. Now, is that a true statement? Is that the answer we were supposed to get? Yeah. So that means we know for a fact that that point falls on that line. Now let's go ahead and try it though with the second equation, because in order for it to be a solution, it has to work for both. So our second equation is y equals 7x plus 1. So substitute 8 in for y and 1 in for x. So instead of 7 times x, it's 7 times 1 plus 1. Simplify whatever side of the equation you need to do. In this case, it's the right side. We have multiple operations here. We have both multiplication and addition. So we must follow order of operations and multiply first. 7 times 1 is 7. And then 7 plus 1 is 8. Does it work for this one? Yes, it does. So that means that this is a solution. I had said that I wasn't going to show you any more on the graph, but because we have our first one that works, I will quickly show this one to you on the graph so you can see how when it does work, it matches that one solution model. All right, so here we are on Desmos again. We have our two equations that are graphed and then our ordered pair, and we can very easily see that is that intersection point that is shared by both, in this case, the purple line and the black line. So it is a solution. We've just kind of confirmed that visually by graphing as well. All right, we're gonna do two more examples together. So sometimes you will get ordered pairs with negatives involved. It's not really any different. You just need to be extra careful that you multiply properly and have the correct sign. So that's really the only extra thing to be careful about is when you have negatives in your ordered pair. But if we start with our first equation here, we're going to substitute -7 in for x and -2 in for y. So our first equation is 3x minus 11y equals 1. So it'll be 3 times -7 minus 11 times -2 equals 1. So let's do our multiplication first. 3 times -7 would be a -21. Bring down your minus sign. 11 times -2 would be a -22 equals 1. All right, let's take a quick pause real quick. Reminder on the minus and negative. Do you guys remember what that becomes? The minus and a negative, they cancel each other out and it becomes a positive. So we have -21 plus 22 is equal to 1. When you add those up, it does in fact give us the answer of 1. So we know that that point works for our first equation. Let's try it out and see if it works for the second one. I'm going to do the work over here to make sure I don't run out of space. So our second equation is 3x minus 14y equals 7. Substitute -7 in for x and -2 in for y. So 3 times -7 minus 14 times -2 equals 7. 3 times -7 would be a -21. Minus 14 times -2 would be a -28. equals 7. What does that minus and negative become? A positive. We have negative 21 plus 28. When we add those up, we do in fact get 7. So because this point worked for both equations, then our answer is yes, it is in fact a solution. All right, this will be the last problem we do together. We want to know if the point 31 is a solution to these two equations here. You will sometimes get an equation that looks like this, that either represents a horizontal or a vertical line. So it's either x equals or y equals. It may look a little different. It may look harder, but it's actually a little bit easier. It's actually going to save you a little bit of time. Because if we look at our ordered pair, remember the first number is our x and the second is our y. So if we have the equation x equals 3, well, the only variable we have is an x. So we only can substitute our x value. Well, our x value in the ordered pair is 3. So we're going to substitute 3 in for x, and we get the statement 3 equals 3. Did that work? Yeah, that's a true statement. So looky there, we didn't have to do any multiplication or addition or anything like that. It just worked right away for us. But we do still need to check our second one here. So our second equation is 6x plus 15y equals negative 9. Now we're going to substitute 3 in for x, and this equation does have a y, so 1 is going to be substituted in for y. So instead of 6 times x, it'll be 6 times 3 plus 15y, so 15 times 1 equals negative 9. 6 times 3 is 18, plus 15 times 1 is 15, equals negative 9. We add that up, 18 and 15 gives us 33. Is 33 equal to negative 9? No, it is not equal. So that means even though it worked for the first one, since it didn't work for our second equation, our answer is no. So that is a possibility that can happen too. It can work for the first one, but since it didn't work for the second one, it's not a solution to both. It is not a answer. So the choice that you would select is no. All right, it is now your guys' turn to hop on IXL and practice this yourself. Remember that IXL does have a video that they have created, which is awesome. So if you want to see a few more examples or see if maybe they do their work a little bit differently using a different method, please check out that video. It is a great resource as well. All right, good luck on this assignment. And if you need anything, make sure to reach out to your teacher. Bye.